Hello everyone. In today's video, we are going to use everything we've learned about spectroscopy, put it all together, and identify an unknown compound using the different data that can be provided to us. Now, the first thing you might do to a sample that you obtain is do an elemental analysis. And this tells us how much of each element you have. For example, if we look at this table, we can see the percentage by mass of carbon, hydrogen, and oxygen contained by this compound. Okay, so we're going to look at a little bit about stoichiometry because we need to use this data to find the empirical formula of the sample. So to do that, what we must do is divide each value by its atomic mass, which we can find on the periodic table. Okay, so 12 for carbon, 1 for hydrogen, and 16 for oxygen. Now, of course, I've rounded it up. You could use more decimal points. So this gives us 11.2, 6.1 divided by 12, 5.5 if we round up, and gives us 1.38. Now the next step in finding empirical formula, if you've done stoichiometry, is to divide all these numbers by the smallest number, which is 1.38. 1.38. We can keep it at that. It should not cause a problem. There might be some rounding issues. We will see. So 5.5 divided by 1.38 gives us 4. Obviously, this is 1. And 11.2 divided by 1.38 gives us 8. So that looks like a reasonable ratio. So this tells us that there are potentially, the empirical formula is C4H8O. So using stoichiometry, we can find the empirical formula, which is the simplest ratio of atoms of each element. Now let's use mass spectroscopy, which tells us how many ions, positive ions, have been detected with a certain mass to charge ratio. We see the first peak is at 72. The first thing you should do is check your formula. Does it add up to 72 or not? So this formula, if we do 4 times 12 plus 8 plus 16, it does in fact add up to 72 grams per mole, which means not only is our empirical formula C4H8O, but it is also our molecular formula. This is actually the amount of atoms we have in our compound. Now, we do see other peaks in the mass spectrum, 57 at 43, and you can use the data booklet to identify those fragments. Okay, now we can see also, just by simple mathematics, that from 72 to 57, you have a loss of 15, which means that you have lost a methyl group. So there's definitely a methyl group in this compound. So that is a little clue that will give us to the structure of the compound. Okay, now please join us in part 2 to see how we can use the rest of the data, infrared and NMR, to understand what is the true structure of this compound. Because in reality, there could be a lot of compounds with the same molecular formula, so isomers of this formula. Thank you very much.